Pleasure of introducing someone who is very well known to the TLMS. He's been the basically he's been the chair of the TLMS since 2021. He's the co-founder and CTO of Hudson Labs, which I like. Hudson's my son's name, so great name. Toronto-based startup specializing in NLP and AI for financial apps. He's also been the NLP leader for the lead at Aggregate Intellect, and he's the co-lead for Privacy Working Group to the Bloom open source LLM project. He holds a master's in computer science from the University of Technology in the Netherlands, and he has a professional background of being a formal software engineer at IBM, as focusing on information and security. Over the decades, he's been experienced in machine learning with initial work going back to 2010 when no one was even talking about machine learning. So we certainly have a great speaker today with a lot of experience. He's going to be speaking today about Retrieval Augmented Generation work. And with no further ado, I'd like to bring up to the podium Suhas. Thanks so much for joining us today.
Hello everyone. Firstly, apologies for my reduced energy levels. I'm recovering from a sickness. But hopefully, I can get through this presentation. So before we start, I want to ask a couple of questions. How many of you here have built RAG applications? And that's a substantial number. And how many of you here are satisfied with the quality of the applications that you have built? That's interesting because I was expecting everyone to raise their hands and I could say, hey, let's then skip this talk and do something else. It looks like we need to discuss about, so in this talk, I'm going to share my experiences with techniques that have worked for me while putting RAG applications, transitioning them from prototype to production. I think I also have to mention I'm writing a book on designing LLM apps. It's O'Reilly. It's coming January 2025. So let's get started. I first want to just start by defining what we mean when we say RAG. I just want to use the colloquial definition rather than going into pedantic debates on technical definitions. So colloquial definition, just connecting LLMs to external data and building applications over it. And what kinds of information we are trying to retrieve, I would broadly classify it into 4 types. The most important and the most prevalent form of RAG is for just connecting it with your external knowledge base and getting information from that. But there are also more recent paradigms, like for example memory, where you can store intermediate results from LLMs, also the conversational history that doesn't fit inside your context window. Also training examples. For example, you can have a repository of prompts that contain instructions for all kinds of tasks. So if you have like a agentic system, it can just fetch instructions from the prompt repository. Or few short examples that you can dynamically retrieve from a large training corpus. Also, the last part mostly related to agents, list of tools, documentation, for example, API documentation if you are trying to generate code, etc. So whatever I'm going to speak in the next 30 minutes is applicable to all of these types of information, but mostly keeping in mind the first part, the knowledge base one. As you all know, RAG 101, very quickly going through it. User sends a query, there's a retrieval engine, you retrieve results, and then ask the LLM to give you a response. But as you all know, it's not enough. Production grade RAG usually has a lot more steps. There's rewrite, where your initial user query has to be rewritten in some form to make it more appropriate. And then your retrieval step is usually several small steps because you have a very large corpus. First, you use a inexpensive method to get the most plausibly relevant documents, and then you have a re-ranker step that takes the initial candidates and filters them further. And then that is not enough, because you then take your retrieved results and then you refine them in some way so that it's more amenable to be used by the generative model. You then insert it into the context, and there are many different strategies for inserting into the context, and then you generate it. So sort of RAG struggles, I guess I don't need to spend too much time. You all know how bad RAG is, but this is something I tried today. Perplexity Pro, GPT-4o backend, which movies are playing at TIFF Lightbox, and it gives the answer. It's completely wrong, and this is not a hallucination, because this is actually, it's just the wrong dates. And similarly, I asked it on WhatsApp Meta AI. It again gives you the wrong information, but it's actually the movies. At some point in Toronto history, these movies showed at those times. Right, so it's not a hallucination. What is actually happening here is a failure in document parsing. So the TIFF website and also a couple of other websites which contain movie information for Toronto are a little hard to parse, and because of that failure in document parsing, it's hard to understand when a date boundary changes. And as you can see, there are a lot of RAG failures are attributable to things that are very high upstream, like document parsing, etc., and not really in terms of hallucination or reasoning missteps. So we'll now go through a bunch of techniques that across the entire RAG pipeline that I would worked well for me, and yeah. So again, starting with upstream, segmentation and chunking. Segmentation, so very few people, and there's very little research work being done on segmentation. Segmentation is, when you have your retrieval units, let's say sentences, how do you define what is a sentence? A lot of current sentence tokenization techniques just depend on punctuation based. For English, like other languages, it gets more complex, but for English, a lot of them just use punctuation-based sentence boundary detection. But that is not enough. Again, as you saw in, if your data sources are like documents from the web that you have to parse, sentence boundaries are not very clearly defined. There is no punctuation, as you can see from things from the TIFF website. So you need a better model for that, and there are more promising models in recent times that are moving beyond punctuation. Segment any text. This paper is something that I would recommend. They also have a GitHub repo, and what they do is they train to predict the probability of a new line token to be the next token in a sequence. So they're using an encoder model, predicting new line occurrences, and then what they typically do is take web text, remove all new lines, and then predict where a new line is supposed to be. Yeah, so you can read the paper for more details, but I think this is where in my, so our company, we have been around for 5 years now, and in those 5 years, I think the single biggest line item that I worked on across the entire pipeline has been on improving sentence tokenization, because that literally determines everything else downstream. If you don't have the right boundaries, you are going to, just a caveat, the text that I work on is financial text, interferes with a lot of numbers, tables, and so on, which is where sentence boundaries are a lot more important. Of course, there are many document types where sentence boundaries are very clearly defined, but more often than not, they are not. So next, chunking. So these are the individual units that you are going to represent either using embeddings or using them to feed into your language model context. So each chunk, you can think of it as an island because it's not connected to any other chunk. And in order for a chunk to be useful, you have to either connect these different related chunks together or make each chunk self-sufficient. And self-sufficient means it needs to contain all the information that is relevant for all the types of queries that it can answer. So chunking failures, and this is no technique that's out there can reliably solve something like this. Imagine you have a very large database page, and then in that there's one document. It says page 5, all document numbers in the document are in millions, but page 123 it says related party transactions amount to $23. So you can't just feed the entire PDF here because this is not just a single PDF rag, it's the entire knowledge base. So you can't just feed it all. But there's no way that these two things are going to be in the same chunk using any chunking strategy that is currently in use. So how do we do chunking at my company? There are a few things: layout aware chunking, knowing the layout of the HTML or the PDF or whichever format, being aware, using that as metadata into the chunking process. Semantic chunking, looking at discontinuities in semantic similarity. So if you have heard of Bollinger Bands in finance, we use a variant of that. And the most important thing, the third one, which is what makes this work for us, is training a small generality versus specificity model. So the idea here being, if you have a more general sentence, then it is going to be more likely to be related to many other sentences. If it's a very specific sentence, then it's not very likely to be related to many other sentences. So if you can train even a BERT-style model on generality versus specificity, and then you rank them by generality, then the most general sentences can be, part of a generic context that can always be added to whenever anything relevant from that document is being retrieved. So let's talk about retrieval now. Let me do a quick time check. 15 minutes in. Okay. So retrieval, and this is where I think there's something very important to note. All current RAG apps are bottlenecked by retrieval, because even if you have the world's best language model, if it has bad context, it's not going to give you the right answer. And with RAG, we are explicitly discouraging the LLM to use its internal memory because we are giving it the context. But if we feed it the wrong context, then it's not good. So that means the retrieval should be as smart as possible. But if you are using something like embedding similarity for retrieval, there's no smartness. Similarity is not a synonym of intelligence. So how do you fix this situation? One way is, so ideally what should happen is the so-called reasoning layer, which currently is fully managed by LLMs, needs to be offloaded to the retrieval part as much as possible. And I'll talk about a few techniques that can help do that. But just in terms of representing information, what I found is doc2query. Just a quick show of hands, how many of you have heard or know what doc2query is? Looks like not that many. So I can, so here in this case, this is a sentence in a document. The company designs, manufactures, and markets smartphones, personal computers, and tablets. Now we can use a very small language model to do a question generation task. So that means, given that sentence, what question does it answer? And the query that model generated is, what are the main activities and products of the company? Now there is a user query saying, what are the company's products? If you do embedding-based similarity scoring, that document will have so many other sentences that are more similar to that user query than this sentence, because this is the sentence that we want because it contains the full information. But if you use typical embedding-based methods that like out-of-the-box embedding-based methods, and try to match this user query with that sentence, this sentence will be like maybe rank 45, and it won't even be retrieved. But if you matched it with the query instead, that is the generated query, it immediately is at the top. So that's why, and this is pretty inexpensive. You can use a small language model, and because it doesn't even need to be the right question, right? It just needs to be something similar so that you can map it in the vector space. So that means, take every document you have, and for every sentence or every paragraph, generate a question using a very small language model, and then use your embeddings to match with those questions rather than the actual sentences. And so that's one very highly effective way. The other one is, of course, fine-tuning embedding models. Fine-tuning language models is, it comes with a lot of risks because it sometimes results in catastrophic forgetting, degradation of current capabilities. But this is fairly low risk, and it's also fairly inexpensive. So when we talk about, so we are thinking about using similarity as a means to determine relevance, or even as a means to determine what will answer our question or not. But it's usually like similarity with respect to what? Every use case has a different with respect to what, right? But the embedding models that are out of the box, they are just dealing with the general notion of similarity. So for example, if you take this sentence 1 and sentence 2, there's sentence 1 is talking about no bankruptcy risk. Sentence 2 is talking about bankruptcy risk. So there are two opposites. They are opposites. And are opposite sentences similar? Yes, in some sense. So it's not unreasonable for embedding models to have these two things in be similar. But for me, for my use case, I want to see, does the company have a bankruptcy risk? And it's very inefficient for me to get all the sentences and then let the language model do the reasoning about whether there's bankruptcy or not. So I can just do fine tuning. I can fine tune so that there is actually a big gap between something saying bankruptcy risk and something no bankruptcy risk. So that's how, like, you can redefine the embedding space in any shape or manner you want. Like, you can build an entire universe where you can say, you can drag things, at different points and facilitate your own use cases. And fine-tuning embeddings is also made possible by so many open source libraries, etc. But this is just one example. We also have a embedding model where it's fine-tuned for getting specific information given a general description. So you give a general description of something and it would match specific instructions. Other retrieval improvements, instruction following embeddings. So imagine that you can, in your embedding query, you would give it an instruction. And so this is a promising field of research. So far, I haven't seen any significant progress. There is something called as instructor embeddings that you can that's available online, which does a very limited version of this. But I'm not going to spend too much time on this. We can discuss it later. But now let's talk about generation. So generation, and this is like one of those cheap hacks. Now you are generating, so you are feeding in top K documents into your LLM, but language models have a lost in the middle phenomenon. Just checking, how many of you have heard of the lost in the middle phenomenon? Quite a few. So lost in the middle means your language model is good at retrieving context at the top of the context and at the bottom, but at the middle, it's the retrieval is the recall is lower. So what you can do is, if you want to bias your model in terms of feeding, selecting the documents that the re-ranker or your retrieval model has said is the most relevant, then you put it something like this. If this is the top K, then you put the most least relevant documents in the middle, so it's not going to yeah. And then also retrieval fine tuning. So lost in the middle is actually something that you can not easily, but you can remove it by using fine tuning. And how you do that? You can take a document, you can generate a dummy data set, and then in that dummy data set, the next prediction, the prediction has to be something that is in the middle of the context. So you are actually teaching it to fetch it from various parts of the context, and just that fine tuning would make any of your open source models a lot better at mitigating the lost in the middle problem. And then finally, instead of retrieving everything at once, let me get a quick time check. 7 minutes. Instead of retrieving everything at once and generate only a part of the output. So this is called interleaved generation. So what this means is you start generating the answer, and then if you feel that the model is likely to hallucinate next, or the model is likely to not know the rest of the answer, it goes back to retrieve. And this is not human in the loop. It is automated. The way you do it is, there are many different ways, but one way could be taking the logits of the next predicted sentence and seeing the confidence level, and if it's not very confident, you think that, oh, this could be a hallucination, so you go back and retrieve. And this time you generate a new question for what we are supposed to retrieve, because you already have a candidate sentence that you have generated. So you know what you are trying to generate, but you just want a fact check. So you generate a query for which that candidate sentence is the answer, and then go and retrieve again. And finally, I want to talk about the importance of tightly coupled models, where this is the original promise of RAG, right? Before the definition of the word expanded, because everyone wanted to say we are doing RAG, and similar with agents. In the last 2 months, I have seen the meaning of the word agents expand, because everyone wants to say we are building agents, which is okay, but the colloquial definition differs, starts deviating from the technical definition. But retriever and generator learning from each other's feedback. So if you look at this, all these steps could be like small models, and each of them is learning from each other's feedback. So the generator model, it needs data in a particular format so that it can give you the right answer. But that feedback can be given to the refine step. The refine is usually, let's say, a summarizer of the retrieved results. So I'll give you an example here, and I'll stop. So this is something that I have been fascinated by, the topic of LLM SEO. So as we have like new ChatGPT, Perplexity, etc., that are trying to be like the next version of Google, how does SEO look like? And I had a real world experience with this last year. So we have this blog post. This is on our website. It's talking about 15 tools for equity research. So one of those 15 tools is our company, but we didn't include it in the list because it's in our website, so it's a given. But when people input that question in Perplexity, they ask, give me a list of equity research tools. Perplexity gets it from here. It parses the information and it shows, but it doesn't include our company because we never had our company's name. Because for a visitor, it's obvious that we are one of them. So we had to, if you go visit this page right now, you'll see our name there, because we had to edit the web page so that Perplexity will show us. So it's, I think, one of the earlier cases of LLM SEO. And I would expect this to be a bigger industry going forward. But you can see here that there is also the case of Perplexity, or the generator model of Perplexity. picking from different sources that is available to it. It's not always picking the first result in Google in its search. It's going to pick from one of them, but the reason why it picks something instead of the other has to do with the ease of document parsing, the ease in which the information is presented, and so on. So this has a lot of implications for how we design websites, but also how we represent information, which is why this refine step here is pretty important. Refine is, in this case, getting your retrieved results and then putting it in a form that makes it easy for the generator model to get the answer. Yeah, so I guess that's the end of the talk.
That was great. Thank you so much. We have for questions, not a lot of time. If you hold your hand up, there's a microphone that will be passed around. We probably have time for about 1 or 2 questions. Oh, so good you didn't have any questions. Nope, one on the floor. Can we get the mic?
Sorry. Hi. I was just curious because I haven't seen a lot of literature on this. So on chunking and embedding recommendations that goes through like log files or large files of like IT data. Because lots of the literature is like on PDFs and and like documentation compared to pure boring IT logs.
Oh yeah, that's a really good point. There's generally not a lot of research literature on many of the upstream tasks like segmentation and chunking. With respect to things like log files, etc., I think it all depends on the use case, what kind of queries are being asked, and the chunk boundary then can be what can you put in one chunk that can answer a typical query, and if it's a single log unit, then that's probably the right one, or again, yeah, it depends on the use case. So chunking is very, very use case specific, although as I mentioned here, there are certain things that are like universal. By the way, I forgot that I had this section, but yeah.
So my question is, have you come across cases where the generator hallucinates a response even when it's given the right context, and numbers that are in maybe somewhere in the middle are not like incorrectly specified?
Yeah. I think the hallucination risk is always present because it depends on the query that you have. And I think this slide also contains a little bit of that. So irrelevant context can act as distractors, and that's an important point. I'll give you an example. We have a financial document, and at the end of the document there is a signature. So I was like, okay, let's use long context. I'll feed the entire document. Now the signature, it's some random person who is signing it off, and they are not really relevant to anything else in the document. But because it exists as a distractor to the language model, and the language model thinks everything that in the document pertains to this person. But just after I remove that signature part from the document and feed it, it's okay. So as you can see, that retrieved context can contain a lot of distractors, and yeah.
Thank you so much, everyone. Unfortunately,